All right, going to the next problem here. Next problem says the cost y for Leah and X friends to go to an amusement park can be modeled by a linear equation. Right? So notice how they already gave me two bits of information that are really crucial. We're given the total cost, which is the variable y, and Leah and X friends. Leah and X friends. So X is the number of friends, Y is the total cost. Now going here, it says the amusement park charges an entrance fee of $45.25 per person and a parking fee of 10 per car. All right. So we can sit here and make a situation, right? Again, notice I haven't even read the question. The first thing I'm going to do is first understand what I'm reading. So I'm given a bunch of information that I can make an equation out of, right? Obviously, the total equation is cost. So what I'm going to do here is I'm going to write that equation. Total cost depends on what? Total cost is what? Well, it is the entrance fee per person. So it is fee per person and a parking fee or a car fee and car fee. So again, notice how all I'm doing is just writing what is given to me. This is the problem that was given. Okay. So now, can I make an equation out of this? The answer is yes. Right? Total cost, y, is equals fee per person. Well, how much is a fee per person? 45.25 per person. Do we know how many people are attending? The answer is no. So I would just get x or times x. And, well, we know and means plus. Well, what is the car fee? The car fee is $10 per car. So I'm going to put 10. Now, you get technical and say, Gons, well, yes, it's 10C because it's a number of cars. But how many cars are going? Well, it says Leah's car has a maximum seating of 6 people. So how many cars are we actually going? Just one. So we don't have to put 10C. We could just write down 10 once because that is the number of cars that are attending. All right. So that's your equation. So notice how from this words, I came up with this equation. Now the next part says, what is the range? Right? And the key word here is range. If you look back at this, oh snaps, that was a little too big, but it's okay. If you look back over here, well, for me to be able to find my range, I first need to identify my domain. So what is my domain? Well, my domain is a set of inputs. So looking at this problem, what is my domain? Well, my domain, which is x, is the number of people going. Number of people going. How many people can go? Well, if Leah's going by herself because Leah and X friends, notice how that is one person. So X can be one person, which is Leah by herself. Can two people go? Yeah. Can three? Yes. Four? Yes. Five? Yes. What's the maximum? Six. Why six, Gons? Because the car holds a maximum of 6 people. This is what you have to be careful about. See? 45.25 per person, $10 fee, maximum of 6 people. So can 7 people go with Leah? No. It's actually altogether is 6. So a lot of you told me this on the OER, but again, you kind of didn't answer the question. So how do you get the range? Well, if my input, my domain is this, we can plug our equation in, or rather we take all these values and put them into this equation. So I'm going to show you using the calculator here, which again, if you told me in the OER, that is not what I wanted to see. In the OER, I did not want you to tell me that you can graph this and look at the table. No, you have to tell me that to get the output, you first take your input and you substituted it. Now, again, for sake of purposes and time here, I'm going to just use a calculator because it's a little bit faster. So again, we have our equation, 45.25x plus 10. I'm going to go to my table because in my table, I can get what I need. All right, so I'm going to go to graph. Again, the equation is 45.25 per person x plus a $10 parking fee. Again, this is the equation. I want to see the table because the table tells me what is the range. And here it is. If Leah goes, it's going to be 55.25. If 2 people go, 150. If 3 people go, 145.75. If 4 people go, it's 191. If 5, 236.25. And lastly, 6 is 21.50. So on your answer, you should have had this. Oh, I'm sorry, not that. Remember, this is my set of inputs. Therefore, my set of outputs, y, equals 55.25. Or what was the second one? 150. The third one was 145.75. 145.75. The next one was 191. The next one was 236.25. 236.25. And lastly, the last one was 281.50. Sit here, delete this. Again, for our sake of time, there it is. I'm going to put it right underneath it. So there it is, right? When the domain is 1, 2, 3, 4, 5, and 6, the respective range is 55.25, 150, 145.75, 191, 236.25, and 281.5. Now notice how, again, this falls into the chapter 2, discrete and continuous. This is a discrete case because we are talking about whole people. Can we have 1.5 people go? No. So notice how I cannot spend $90. You have to go with what is given. All right. So that's problem number 3. So again, this is your output. And again, for you to get full credit, for me to count this as 100 so I can average out your grade, you must have everything written down. So please make sure you're copying everything down. Next problem here. Which of these sets of ordered pairs below do not represent a function? This is probably one of the easiest problems. The keyword here was not represent a function. Well, we talked about this extensively in class. Function is when an input has exactly one output, right? And I even told you when you took your notes, the most important, the easiest way is x cannot repeat. That is by far the easiest way to remember. So all we got to do here is look at the x's and see which x repeats. So in this case, I'm going to look at my x's and I'm going to highlight any that happen to repeat. So looking at A, I have 1, 2, 3, 4, 5. Does x repeat? No. So A is a function because x cannot repeat. Look at look at B. 2, 4, 6, 8, 10. Do any of those repeat? No. They're all different. Let's look at C. 0, 2, 3, 2, 9. Uh-oh. Wait a minute. Something's not right here. 2. Oh, let me do that again. Let's just circle it a little bit bigger here. 2 and 2 repeats. So again, a function means that every input has exactly one output. And actually, speaking of which, let me go and correct that here. A function is when every input has exactly one output. Remember, this was a shortcut way. X cannot repeat. There it is. My answer is C because C is the only set of points that have a repeating X value. So my answer would have been Charlie. And again, notice how this is all about reading carefully, guys. Now again, can we continue? Yes, look. D, 1, 2, 3, 4, 5. None of those repeat. The only ones that have a repeating X is C. Therefore, C is my answer. All right, all right. Let's move on. Oh, my apologies. Let's go to this one. This was another easy problem if you took good notes and if you paid attention. The keyword here is which represents a functional relationship. What are they asking for? All they want to know is which one of these is a function. Function. Now, again, we talked about this in class. A function, and we're going to do it again, is every input has exactly every input has exactly every input has exactly one output. Now, if you took notes in class, which we should have, right? We also talked about graphs. Notice how the first scenario here, over here, we talked about points. In this case, we talked about graphs, and we had what is the vertical line test. You guys remember the vertical line test? Vertical line test allows us to see which points duplicate. Vertical line that shows when x repeats. So looking at this, again, you should have all this on your paper. Let's look at what's given here, guys. Draw a vertical line here, right? Look. How many times did that I apologize again. I know that these are not straight lines, but look, how many times did this cross the graph? Twice. What about this one? Twice. If you actually look closer here, this is a vertical line. Look, I'll actually finish it off going top and bottom. That has a vertical line. So which is the only one that does not have a vertical line that crosses 2 points? H. Again, for those of you that are being technical, Mr. Gons, that's not a perfect straight line. I will do it for you. This ain't any better. Oh my gosh! But you get my drift. All right. So there it is. Again, this was this problem. Which one of these shows a functional relationship? Again, this is all vocabulary, guys. All vocabulary. Function. Function is every input has exactly one output. In terms of graphs, what does that mean? That means that we look for the vertical line test. A vertical line shows when x repeats. So again, notice how here, this means that -4 has 2 points. 1, 2. This means that -3 has 2 points. 1, 2. Looking at here, x is 3 has 3 points. 1, 2, 3. The only one that passes it again is this graph here. If you draw a vertical line, look, once. 2 vertical lines only cross it once each time. All right.